My work is basically about compressing multilingual language models and finding the effects of this compression methods. So we focus on pruning. There are different types of compression methods, but we focus on pruning specifically because it's one of the most popular ones. So multilingual language models are usually very large because it's a singular model that accommodates several languages. So its capacity has to be large enough to accommodate those languages. And this makes deploying it very difficult. So compression is usually applied. One such compression method, like I said, is pruning. So pruning this method, pruning these models usually leads to a negligible loss in top-line metrics like accuracy or F1 score or blue score or whichever metric you're using. But we go beyond those metrics and explore the kind of hidden impacts of this across languages. So how does pruning a multilingual language model affect a certain language of a certain resource size or from a certain language family or a certain language that is not present in the pre-training corpora or just different questions like that. So going beyond top-line metrics and exploring the far-reaching effects of compression on languages. So at the time, I was in my master's in University of Waterloo, and I've been working a lot on multilingual language models, how they work, why they work, pre-training them and all of that. So again, I noticed that these models were getting way bigger, right? And I also started to just dip my feet in compression a little. And I had met Sarah in 2019, Sarah Hooker, at the deep learning endeavour in Kenya. And I was familiar with the work on compression and bias estimation and all of that. So one of our most popular work that I'm very familiar with was the what do compressed models forget, where she compressed models and explored the effect on different data sets, image data sets. So I thought, well, why wouldn't we apply this to languages as well? So basically a model of Sarah's work, but for multilingual language models and exploring the effects on different languages. So I shared this with a collaborator called Cohere, and we reached out to Sarah, and yeah, it just kicked off from there. I kind of had an idea of what it was going to be, right? But we kind of followed, like the broad question is the same, but more experienced collaborators like Sarah, Sebastian German, and Julia Kritzer were really helpful in framing the research question and deciding the scope as well. So I think they did help a lot in that regard. So for instance, we had some results, and knowing how to kind of fit that into our research question, and knowing the narrative to sell, right, was more of their contributions as well. And I think with regards to the scope and everything, like the number of languages, the data set choice, it was from a lot of research, seeing what is done in the community, seeing the most popular data sets, deciding on the task to focus on, because we focus on entity recognition, mostly because it was the only task that had a wide coverage of languages, because we investigated 40 languages, and there's a few data sets that cover that many languages, non-translated as well. So so I think the senior collaborators have been really helpful in that regard in terms of framing the scope and all of that. So one result that surprised me was how deciding whether or not to prune the embeddings of a multilingual language model um, um, yielded different results. So when you prune and also during perturbation as well. So we explored perturbing the data set, trying to explore how robust the upfront multilingual language model is for perturbed data set. So we did this in a multilingual setting. So we have, like I mentioned, the task was name entity recognition. So if we have an entity, say a name in a certain language, like French, we can swap that with another entity from English, right, from the English data set. So we did this like in script, so with languages within the same script. So say English and Yoruba. Yoruba is written in Latin script as well, or in family, Yoruba and Igbo, for instance, who belong to the Niger Congo family. So we just swap out the entities, and it was surprising that dense models, that's fully connected models without pruning, they performed poorly on this task, on the perturbation task. But when you did some pruning, it did help. It did help with on this part of the data set. So finding out that pruning improves robustness was a surprising result, especially because this was kind of contradictory to previous findings. And also find out that when you prune the embeddings, this changes. So when you prune embeddings, it loses its robustness as well. It's robustness, just like the dense model. So that was surprising as well, and it really shed some insight into how important embeddings are in multilingual language models. I think the major one was so that was my first time working with TPUs, right? And yeah, I did I did battle a lot with them. Yeah, so I think that was a major setback. I did battle a lot with TPUs and debugging and all of that stuff. So yeah, that frustrated me sometimes, but but I'm glad it turned out well. But with regards to the research itself, I don't think there was any setback. Yeah, maybe time. Like if we, so the fact that it was a very broad, it was a collaboration amongst many people meant the pace was kind of slow, right? So, yeah, but we made it work in the end. So for one, I think exploring other compression methods, right? In our work, we explored only pruning, but these days quantization is picking up, compressing to int 8 to I saw one about int 4 the other day, I think, and yeah, so exploring different other compression methods and seeing the impact of applying them on different languages, right? So quantization, knowledge distillation, and other possible compression methods. Also extending to more tasks, we focus on only named entity recognition, but this may be different if you focus on text classification or generation tasks like machine translation or summarization or question answering or something. So yeah, I think those areas would be interesting to explore. I think also there's a lot more larger language models these days, right? So there's a lot of talk about emergence and how the ability of language models, how they gain different abilities the more you scale them up. So maybe our results will only hold in smaller scales, relatively smaller scales, right? So maybe if we're dealing with several billions of parameters, it doesn't hold. I think that's another interesting area to explore as well.